Hello everyone, my name is K. Srinitya. Today I am going to discuss about the understanding Zener diode, breakdown mechanism and applications and their uses. Introduction to Zener diode. Zener diodes are special types of semiconductor diodes designed to operate in the reverse breakdown region. Unlike standard diodes that are typically damaged by reverse breakdown, Zener diodes are engineered to withstand this condition and maintain a stable voltage across the terminals. This characteristic makes them invaluable in various voltage regulation and protection circuit. Here the image tells everything. Genodiode structure and symbol. A genodiode is a heavily doped p-n junction diode. The heavy doping results in a narrow depletion region. The symbol for a genodiode is similar to that of standard diode, but with bent ends on the cathode bar distinguishes it from a regular diode. Breakdown mechanism. Two primarily breakdown mechanisms can occur in a reverse bias diode. Which breakdown mechanism occurs in a reverse bias diode? Zener breakdown occurs at low reverse voltages and characteristics. Tunneling of charge carriers. Here avalanche breakdown occurs at higher reverse voltages, involves multiplication of charge carriers through collisions. Here Zener breakdown mechanism. Zener breakdown occurs in heavily doped p-n junctions with a narrow depletion region. The strong electric field in the depletion region can directly break covalent bonds, generating electron-hole pairs. These carriers are then accelerated by the electrical field, resulting in a large reverse current. Voltage dependence. Zener breakdown typically occurs at lower reverse voltages, typically below 5 volts. The breakdown voltage is highly dependent on the doping concentration. Higher doping leads to lower breakdown voltages. Temperature coefficient. Zener breakdown has a negative temperature coefficient. As temperature increases, Zener voltage decreases slightly. Here the picture. Temperature coefficient, negative effect on Zener voltage, voltage dependence, lower voltage due to doping, electric field, breaks covalent bonds in depletion region, electron hole pairs, generated carriers, accelerated current. Here the Zener breakdown mechanism represented in the diagram. Here avalanche breakdown. The mechanism avalanche breakdown. Avalanche breakdown occurs in lightly doped p-n junction diode with a wider depletion region. When reverse voltage is applied, minority carriers gain kinetic energy as they accelerate through the depletion region. If the voltage is high enough, these carriers collide with atoms in the crystal lattice, ionizing them and creating new electron hole pairs. These newly generated carriers also accelerate and collide with other atoms, creating an avalanche effect of rapidly increasing current. Voltage dependence. Avalanche breakdown typically occurs at higher reverse voltages, typically above 5 volts. Temperature coefficient. Avalanche breakdown has a positive temperature coefficient. As temperature increases, the breakdown voltage increases slightly. Here the clear information about the avalanche breakdown process. First, stable diode. There is no current is flow. Carrier acceleration. Minority carriers gain energy. Next, carriers collide, creating pairs. Then rapid current increases. Then high reverse current is occur. Zener diode breakdown effects. Here, Zener diode characteristics. Combination of effects occurs around 5 volts. Reverse breakdown voltages. This is the key parameter of the Zener diode. It is the specific reverse voltage at which the diode begins to conduct significantly in the reverse direction. Zener impedance, represented in capital Z small z. This is the dynamic resistance of the Zener diode in the breakdown region. It represents the change in voltage for a given change in current. A lower Zener diode impedance indicates a more stable voltage regulation. Maximum power dissipation. This is the maximum power that the Zener diode can safely dissipate without being damaged. It is determined by the diode's voltage and current ratings. Temperature coefficient. As mentioned earlier, Zener diode has a temperature coefficient that indicates how the Zener voltage changes with temperature. Zener impedance. Stability indicator in breakdown region. Second one, reverse breakdown voltage. Core parameter of a diode operation. Third one, maximum power dissipation. Safety limit for diode operation. Temperature coefficient. Influence of temperature on voltage. Advantages of Zener diodes. Simple and inexpensive. Zener diodes are relatively simple and inexpensive components. Stable voltage regulator. They provide a stable voltage regulation over a wide range of input voltage and load current variations. Fast response time. Zener diodes have a fast response time, making them suitable for application requiring quick voltage clock. Simple and inexpensive and stable voltage regulation, fast response time. Limitations of Zener diodes. Zener impedance. Voltage variations occurs with current changes due to impedance. Limited power handling. Zener diodes cannot handle high power levels. Temperature sensitivity. Zener voltage changes with the temperature, affecting accuracy. Disadvantages of Zener diodes. Limited power handling. Zener diodes have limited power handling capabilities. Temperature sensitivity. The Zener voltage is temperature dependent, which can affect the accuracy of voltage regulation. Zener impedance. The Zener impedance can cause voltage variations with changes in current. Here the conclusion. Zener diodes are essential components in many electronic circuits, providing a simple and effective way to regulate voltage and protect sensitive components from over voltage condition. Understanding the breakdown mechanism, characteristics, and applications is crucial for designing reliable and efficient electronic systems. While they have limitations, their advantages often outweigh the drawbacks, making them a valuable tool for electronic engineers and hobbyists alike. Exploring the multifaceted role of Zener diodes. Zener diodes as breakdown mechanism. Zener and avalanche breakdown mechanisms explained characteristics, key electrical characteristics of Zener diodes, applications used in voltage regulations and over voltage protection. Advantages: simple, effective, and reliable voltage regulation. Disadvantages: limitations includes temperature sensitivity and power dissipation. Here is the clear explanation about the Zener diodes reverse breakdown voltage. Thank you all.